Alright, next one. Hopefully this one won't take me 7 tries. In the system shown above, the block of mass m1 on a rough horizontal table, the string that attaches it to the block of mass m2 passes over a frictionless pulley of negligible mass. That just means the pulley doesn't change anything. The coefficient of kinetic friction mu k between m1 and the table is less than the coefficient of friction, static friction us. We already know that. I'm not sure why that would be particularly helpful. They're just saying mu k is less than mu s. We already know that's true. We've talked about that before. Harder to get something started moving than to keep it moving. On the diagram below, identify all the forces acting on mass m1. Okay? It has a weight. It has a normal force. I suppose I should call this weight 1. It has tension from the string. There's only one string, so I don't need to number it. And the problem says there's a coefficient of friction, so there's clearly friction on the table. So if the pulley's pulling it to the right, friction resists that, not the pulley. If the string's pulling it to the right, friction resists that, and so there's friction to the left. Check. In terms of m1 and m2, determine the minimum value of mu s that will prevent the blocks from moving. Okay. So my answer should only have m1, m2, and gravity, since that's a known thing, in it when I'm done. This is a static equilibrium problem if I want to know what's going to prevent them from moving. So prevent them from moving means they're at rest. At rest. I'll also probably need a free body diagram for mass m2, so let's scroll up and do that real fast. We've already done m1. Mass 2 has its weight for mass 2, and it has its tension. Alrighty? So we need to do both masses. Mass m1, probably should color code here just like last time. Let's do mass m2 in red and mass m1 in blue. So this is m1. Mass m1 has up, down, left, and right forces. So F up equals F down, and left equals right. So its up forces are normal, down force is its weight of box 1. My F's look really bad. Left force is friction, and right force is tension. Tension. It's a T. Trust me, that's a T. Now I'm looking at box 2. It only has up and down forces, so up equals down. Tension equals weight for box 2. I want mu s. So if I think about the equation that involves mu s, that's force of friction equals mu s times the normal force. So I need to know the normal force and the force of friction. Well, normal's right here, friction's right here, and I need them in terms of m1 and m2. So let's get busy and change these equations into m1 and m2 and see what happens. So I'm going to take this first blue equation and write it in terms of m1 and m2. I've got the normal force equals Fg1, which is m1 times g, so I just replaced Fg with mg. Tends to freak people out, so please don't freak out. Ff is what we're looking for here from the tension, so I can't rewrite that equation. There's nothing there to rewrite. I don't know Ff and I don't know tension. I can, however, take this equation here and rewrite it. Tension equals Fg2 is really m2g. Oh, and look at that. Now I know tension. Check, no tension. I know normal force. Now I just need force of friction. So according to this equation here, the force of friction is equal to tension. So let's bring it over. Ff equals tension. Well, the tension's just m2g. So Ff equals m2g. Since that was my tension, I just took this tension, put it right there. Well, now I've got Ff, I've got my normal force. So looking at this equation, sorry I didn't give myself enough space, so this is getting kind of scattered. Looking at this equation here, if if I solve for mu s, I just divide by normal force, so FF over the normal force equals mu s. My normal force is right here. FF is right here. So let's write that, plug that into the equation I just found. FF, the top part, is m2g. Fn is m1g. That equals mu s. Oh, look at this. G's cancel. And I've got m2 over m1 equals mu s. Fascinating. Isn't that cool? Alrighty, there we go. Part B done. Alright, the blocks are set in motion by giving m2 a momentary downward push. In terms of m1, m2, and mu k and g, determine the following. The magnitude of acceleration of m1. This is no longer an equilibrium problem. There is acceleration, making this an Fnet problem. Fnet equals mass times acceleration. I want the acceleration of box m1. There are two total boxes, so I'm going to have two Fnet equations. Let's put those together. I'll color code again. So looking back up, box 2 is red, box 1 is blue. Box 1 is only going to move in x, so it'll only move left or right. Box 2 will only move in y, so I'll do Fnet x for box 1 and Fnet y for box 2. Okay, so box 1, Fnet x equals m, and this is box 1 times acceleration, and they'll have the same acceleration, they're connected. Net force in x for box 1, it has on it, if we look back up, tension and the force of friction. We're going to need to decide which way we want to be positive. The box is going to move to the right, that's pretty obvious. So let's call to the right positive x, and we'll keep up as positive y. Okay? So in that case, tension is positive, force of friction is negative. Those are only x forces, so that's m1a. Alright, on box 2, Fnet y for box 2, we said it's going to move in y, m2a. It has tension up, weight down, and that equals m2a. Alright, so I could easily find FF. I found the normal force earlier. And the problem says I get to use mu k. So let's write FF as what it really is. We'll keep tension as T for now. Tension equals, okay, so mu k, sorry, not equals, tension minus mu k times the normal force that I found earlier, which was m1g. So mu k times m1g. All I did here was look back at my previous problem, said, look, here's the normal force. The problem gives me mu k, says I get to use it, so mu k times the normal force is force of friction. And that's equal to, still, m1a. May have to cheat again and use the space for part D. I could go ahead and eliminate the tension by solving for it and then substituting. So why don't I solve this equation for tension? So tension equals m1a. I'll add mu k times m1g to both sides, plus mu k times m1g. Now I'll substitute this tension in right here. And so that equation becomes m1a plus mu k m1g, that was all for tension, minus fg, and that's fg for box 2. Why don't we go ahead and write this fg as what it is, m2g. So fg became m2g equals m2a. Right now I'm solving for acceleration. So let's get all the accelerations on the same side. I'll subtract m1a over here. Mu k times m1g minus m2g equals m2a minus m1a. I can factor out that a. I get m2 minus m1 equals mu k m1g minus m2g. I dropped a g right here. m2g. Pausing for a second here. I'm noticing that this box m2a, so up here this box is falling down. So I'm going to go ahead and recognize that and have that acceleration be negative, 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 negative. Just carrying the negative through, which means m2a is negative here as well. Or that a is negative. I'm going to just leave the negative with the m2. Hopefully that doesn't confuse people. I tend to do that a lot. I forget my sign when I start out. So that box falls down, meaning that its acceleration is negative. So I'm just making this whole term right here negative. And as I said yesterday in class, if you forget to do that, make it negative, the most it costs you is a point. Not a super big deal, but it is important. And hopefully I forgot it so many times that you'll remember it. My forgetfulness will help you remember it. All right, now we divide by the stuff that's not a, negative m2 minus m1, negative m2 minus m1. Okay, and mu k m1g minus m2g over negative m2 minus m1 equals a. Looks like we got it. That's our acceleration. Now if you can read it, maybe not on my paper but on yours, now we're finding the tension. Well, we already solved for tension right here, so let's just plug this a in for tension. So that then becomes tension equals m1 times all the stuff we just found for a, mu k m1g minus m2g over negative m2 minus m1. Alright, so that was m. That's the a right there, so that became a. This is going to get too sloppy. I need to scroll down some more. Okay. So, let's just pretend I didn't write this part because it's just going to get sloppy. I'm still taking this t and putting this right here in for a. Now I've got lots of space. T equals m1, and now the a I just found, mu k m1g minus m2g over negative m2 minus m1. Okay, that's a. Then just continuing the t equation, plus mu k times m1g. Golly jeepers, that looks like it's it. Okay, I think we're done. Looking at it again just to be sure. Yeah. Alright, we found tension, we found acceleration, problem done. And that's all. Took a while, but there we go. If you know these three problems, super ready for the test. The end. See you Tuesday.